Hello everyone. In this video we'll be reviewing compound interest, looking at things to keep in mind when considering new opportunities, and anticipating startup or operational costs. So first we're going to look at compound interest. In this chapter we're going to calculate the costs of operating a business, and businesses often need to take out loans to cover costs. To calculate the total cost of a loan, you need to be able to calculate compound interest. Compound interest is calculated on the principal plus any previously accumulated interest. So the formula for compound interest is here. A is the amount of money you have to repay for the loan. P is the principal, the amount that you borrowed. R is the interest rate as a decimal. So if you're given something like 18%, that as a decimal you need to divide by 100 and you would get 0.18. N is the number of compounding periods per year. So typically you'll see an N be annual, which would be 1, or semi-annually would be 2. Quarterly would be 4, monthly would be 12, weekly would be 52, and daily would be 365. So let's see how we can apply this. In this question we need to calculate the total amount to be repaid and monthly payments for the following loans. So first we're looking to borrow $8,000 at 4.5% per annum, compounded semi-annually for a 2-year term. So let's start by writing down what we know. We know the principal of the loan is $8,000. We're borrowing at 4.5%, so that means the rate, R, is given by 0.045. If we're compounding semi-annually, that means N equals 2. And given a 2-year term, T equals 2. So given our compound interest formula, we just need to plug in what we know. So P is 8,000, R is 0.045, N is 2. The exponent will be 2 times 2. So we need to make sure we adhere to the correct order of operations when we're trying to determine the amount to be repaid. With our calculator, I would start by dividing 0.045 by 2, and I would add 1 to that number. So that's the bracket done, and we need to raise this to the power of 2 times 2. Now 2 times 2 is 4, so we need to raise this number to the power of 4. And now we need to multiply that number by the principal, which is 8,000. So the amount to be repaid is $8,744.67. So we have $8,744.67. That's the amount that needs to be repaid. And if that amount needs to be repaid over 2 years every month, there's 12 months in a year, and we multiply that by 2, so there's 24 months total in 2 years. So if we divide this amount by 24, we get a monthly repayment of $364.36. In part B, we're borrowing $8,000 at 4.5% per annum, compounded semi-annually for a 5-year term. So it's largely the same as part A, with one change. T is now 5. So again, starting with our compound interest formula, we put in what we know. 8,000 is the principal. 0.045 is the interest rate. If we're going semi-annually, N is still 2, and we raise that to the power of 2 times T, which is 5 this time. So we do this again, making sure we stick to the proper order of operations. Do this first, and then raise that number to the power of 10, and then multiply that result by 8,000. You may be able to get away with typing this all into your calculator at once, but that might backfire sometimes because your calculator doesn't always know what order you want to do the operations in. It just does exactly what you tell it to do. So the amount to repay on this loan is $9,993.63. And if we're repaying that over a 5-year term, 12 months per year times 5 years gives us 60 months. So we need to divide the amount to repay by 60, and that gives us a monthly repayment of $166.56. Moving on to question number 2, Graham needs a $5,000 loan. One bank offers him a rate of 3% per annum, compounded quarterly for 2 years, and another bank offers him a rate of 2.25% per annum, compounded monthly for 3 years. How much would Graham have to repay for each loan? So let's start with the first bank. They offer 3% per annum, compounded quarterly, so N equals 4, for a period of 2 years, so that's T, and the principal for either option is going to be 5,000. So starting with our compound interest formula, we just plug in what we know. The principal is 5,000, the interest rate is 3%, which as a decimal would be 0.03. We divide that by the number of compounding periods, which is 4, and raise that to 4 times 2. So doing this in our calculator, we'll go 0.03 divided by 4, add 1 to that number, and raise that number to 4 times 2. So 4 times 2 is 8, so the exponent will be 8, and we need to multiply that by 5,000. So that's $5,307.99. So that's option 1. Let's have a look at option 2. So the other bank offers 2.25% per annum, compounded monthly, so n equals 12, for a period of 3 years, so t equals 3. Again, starting with our compound interest formula, we just plug in what we know. So 5,000 is again the principal. The interest rate this time is 2.25%, which as a decimal is 0.0225. We divide that by the number of compounding periods, which is 12, and raise that to the exponent of 12 times 3. So making sure to do this first, raise it to the exponent of 36, and then we multiply by 5,000. The result of this calculation is $5,348.81. So it looks like he will have to repay slightly less for the first bank than the second. Next, we need to calculate the monthly payments. So with the first bank, we're going over 2 years. There's 12 months in a year, so 24 months total. If we divide the amount to be repaid by 24 months, we get a monthly payment of $221.17. The loan from the second bank is over a period of 3 years, and 12 months per year for 3 years gives a total of 36 months. So if we divide the amount to be repaid by 36, we get $148.58. So although he'll have to repay more if he goes with the second bank, his monthly payments are less. And if you have a number of other operational costs, it might be better to go with the lower monthly payment. However, if he can afford to stomach the larger monthly payment, it would probably be more beneficial for him to go with the first bank because he'll save a little bit of money in the long run. So running a small business is often time-consuming and challenging, but the results can be rewarding if you plan well. Business owners usually start with an idea of something they're interested in, be it a service business or a retail business. Before opening a business, it'd be helpful to do some research to determine if the business is right for you, if you're committed enough, if it's feasible and profitable, and are there enough potential customers to support your business. So we're going to have a look at an example right now that addresses this question. So in this scenario, we have somebody looking to open up her own daycare. She currently lives between Moose Jaw and Regina, Saskatchewan, and is trying to decide where to open her daycare. Moose Jaw has a total population of 33,274, approximately 6% of which is 5 years old and under. There are 30 licensed daycares operating in the city. And Regina has a population of 193,100, approximately 6% of which is 5 years old and under, and there are 142 licensed daycares operating in this city. So first we need to determine how many children are aged 5 and under in Moose Jaw and Regina. So the population of Moose Jaw is 33,274, 6% of which is 5 and under. So in order to find 6% of this number, we multiply by the percentage as a decimal. So that gives us a population of 5 and under, which is 1,996. And for Regina, the population is 193,100. Now 6% of that population is 5 and under. And when we do that multiplication, we get 11,586. So based on this calculation, it looks like Regina has a larger population that might support a daycare. But we also need to account for how many licensed daycares there are already. So for Moose Jaw, if we split 1,996 children among 30 licensed daycares, we get 67 children per daycare. And given that Regina has 142 licensed daycares, if we split 11,586 children among 142 daycares, we get 81.6 children per daycare. So assuming children are spread evenly among the existing daycares, the daycares in Regina tend to be more full, so it's likely there's a higher demand in Regina. So part 1 of your assignment is here, page 296, 3 and 4. And now we're going to look at working with startup and operating costs. So when you start a small business, you have to take into account all of the startup costs. So you need to calculate what amount you have to invest or spend before you can open for business. If you do not have enough money saved, you may have to take out a loan or adjust your spending. When considering starting a business, you must be careful to think about all the items that will be needed, including the cost of a business license. You should also allow for some unexpected costs. Startup costs are often one-time costs, such as buying a cash register for a store. In addition to these expenses, you will also need to consider operating expenses. These are expenses paid to keep the business running and are often recurring, such as a monthly phone bill. So now let's try identifying some possible startup costs for a random business. So in this question, Dean is opening a dog daycare in his community. He has researched the market and decided that the business is feasible, and we're looking to identify at least 5 items that he needs to consider as startup costs. Depending on Dean's situation, he may need to rent a space to operate his business, and that rental might require a damage deposit. He may also need a business license. He might need a cash register. He may need to do some renovations to the building to set it up for a dog daycare. One other thing he may need to consider is to stock up on food and medication. So here's the rest of your assignment, page 299, number 6. That's it for me for today. I'll see you next time.